Hello and welcome to the course Neural Networks for Computer Vision and Natural Language Processing. Today is the first lecture, Module 1 Part A. The topic of today's lecture is Introduction to the Learning. In this lecture, we are going to introduce the machine learning and discuss about various applications of machine learning. Then we try to understand what is the basic difference between programming and learning. Then the main three learning paradigm for namely supervised learning, unsupervised learning and reinforcement learning are being discussed. I would like to start the lecture with a very old stories. In 1959, two scientists, Hubel and Wessel, did a very interesting experiment. They want to understand the neuronal response of a living animal for a visual stimulant. Okay, so what they did? They put two microelectrodes into primary visual cortex of a anesthetized cat. Actually, the primary visual cortex of a brain of an animal where the neuronal response is supposed to start. Then they arrange and monitor such a way that any such neuronal response from this primary visual cortex is going to be visualized in this monitor as a spike. Okay, and then they put some slide in the optical slide presenter and they put some images like fish or another cat so that it visually stimulate or is going to excite this cat, and they expect some neuronal response which can be seen as spikes. But they'll be surprised that initially no such spikes have been observed. But there is some spikes is coming when they are changing the slide, this optical slide. Initially they thought that basically noise. But when it comes regularly, when changing the slide, they observed the thing bit seriously and concluded that when changing the slide, there is some spikes is coming, and this is due to that this primary visual cortex area, this neuronal response are basically due to not by a very complex image rather than a very primitive geometrical patterns or primary patterns like line, slanted line, horizontal, vertical lines. And that was a huge innovation, even most in 1959, which is basically a foundation of today's deep learning computer vision. And they got Nobel Prize for their such a rigorous innovation. Now we're going to define machine learning. In 1959, Arthur Samuel defined machine learning such a way that it's a field of study that gives computers the ability to learn without being explicitly programmed. So machine learning is not a normal program. Like if we consider matrix multiplication. If we had been asked to do matrix multiplication, we can write in Python, we can write in C, such and such programs, and for when we give it valid matrix, it will give the answer. And one important thing that when we give the same input, we always get the same output. But in case of machine learning, we'll see in our this course of understanding or course of learning that this, when a machine learns, it improves by virtue of new and new experience. Okay, and that is the main difference on machine learning for a normal programming. Okay, now before we going further, we can say nowadays machine learning is everywhere, from healthcare to autonomous drives and robotics, from recommendation system or personalization system to finance or banking, in natural language processing, computer vision, why not? So at this moment, machine learning and its advanced version deep learning come a huge implications from academics to industry, from research to different kinds of applications, the human day-to-day life. So without will come different application for different machine learning in due course. So with this, we try to understand that what is the learning problem. Now Tom Mitchell in 1998 defined a well-posed learning problem. What he has said, a computer program is said to learn from experience E with respect to some task T and some performance measure P. If its performance on T as measured by B improves with experience E. That means if this happened, we can say it is a well-posed learning problem. But now this definition, although clear, but we try to understand it with an example. There is a movie recommendation system. Now, what is the task here? A machine is being asked, or a computer is being asked, say, that recommending movies for a particular user or a particular set of users. Then that user is likely to watch and enjoy these sorts of movies based on some experience. What do we mean by experience here? There is a set of examples that look, these are 10,000 examples that these movies are liked by these sort of observers or these kinds of users. So there is some labeled examples have been given. That is called experience. And performance, how the program that we are being given, a machine is being given this task, how efficiently the model or the machine is going to recommend, that is the performance. So 3 tasks we have defined, and based of these 3 tasks, can we again just try to understand what is the definition. This computer program is said to learn from experience E. Now we understand what is experience E. A set of examples with respect to some text T. Now in our case it's a movie recommendation, and some performance measure P. That means how we measure the performance, what is the accuracy. Now if its performance on T, task T as measured by P is improved with experience, from the very initial point of view, that if experience is bigger or greater, in general the accuracy improves. Not always true, but still it, then we can say it's a learning. Okay, so this is the very primary or a fundamental definition of learning. Now there is a different types of machine learning. As you see, this is supervised learning, where this kind of annotated examples or labeled examples have been given. There is a different sorts and regression, classification, etc. Then unsupervised learning, where this kind of labeled data are not there. Data are given, but it is not that. It is said that, okay, look, this is a cat, this is dog, and you have to differentiate between these. This labeling is not there. So it's a called unsupervised. No, supervised there is samples or experience is not given. Then there is a different kind of unsupervised. Maybe fully unsupervised, nothing is given. Only that data is given. Then there is some semi-supervised. Few data may be annotated or labeled, and other mostly is not. And some self-supervised, where the data itself, the some inherent or intrinsic property of data is going to use as a clue for this kind, some kind of labeling. So this is self-supervised. We'll come in that. Another very different type of learning is called reinforcement learning. That is basically agent-based learning. They try to find that there is a state and action. Given a state, the kind of action, and based on how good the action is, they got reward. In this way, they understand how to do, what to do for a particular. Some gaming strategy are basically a very good example of reinforcement system. So what we have find that in machine learning there is a main three things. In this course, we basically do now discuss this supervised, unsupervised, and okay. We will start with supervised learning. So first of all, what do you mean by supervised learning? Now, supervised learning is a type of machine learning where the model is trained on a labeled data set. So first you have to understand what do you mean by labeled data set. Now here you see these images. The image is given and it is labeled. Look, this is a cat image. And it's a image is given and say it's a dog image. This is another dog image, it is labeled. This cat image, it is labeled. So when some instance of data, this is a vision example. We can say, we can write a sentence and look, this is a sentence. We can write word, look, this is a word. You write a paragraph, we write it, it's a paragraph. So this way, when a data instance are labeled or can say annotated, then we can't say this is a labeled data set. So this means the input data comes paired with correct output, the labels. So what is actual goal or agenda of supervised learning? There is a paired data. One is data instance. Here it is an image, and there is some label. So instance or data to its label, this mapping. So this supervised learning allows the model to learn the mapping from input to output. What do we understand? The input is our data instance and output is our label. So these examples have been given. By virtue of this example, we have to find a mapping function between input to the output from data to label, so that any new data come, we can label it out. So that is the basic purpose of supervised learning. Now in general, two types of supervised learning we are going to see. One is regression. What is regression? When the output is real valued data, so that we can predict some real numbers like temperature, price, etc. And another is classification, when we predict some discrete valued data or discrete categories. Okay, so that means, okay, this is a cat, this is a dog, this kind of thing is a discrete data. Okay, so it's a yes, no, or cat or dog, something like that. So this is the main issue of the supervised learning, that they will be trained on a labeled data set, and they have to map from input to output, from data instance to its level, and this is two type of regression and classification. Okay, now take a example of regression. You see here, this is a paired data x1 y1 x2 y2 xm ym. Now this is the x-axis, this is the y-axis, this is the year, and this is the September Arctic sea ice extent. So there are some values. Now you can see here, these are the blue dots are the data. What do you mean by data? These are examples, because if you project it on this axis, you can get a value. From this x value, we can get this y value. So such and such data is given. So what is the purpose, or what is our goal for this regression? We can find out a curve. That may be a line, this is a linear regression. That may be a curve, or it's called curve fitting kind of thing. So learn a function fx that predict the probability given x. So if we can find such kind of function, later we can say it's called a hypothesis function. It may be anything, it's a straight line, it's a curve, so that we can get a kind of mapper from x to y. That means any given x, we can get y. So, and it, you can see, it basically predicts the continuous value output. So this is the basic idea of the regression. Now, what is the classification? This is also another type of supervised learning, as we said earlier, and it's going to categorize the data. Given the two samples, there is a plus and minus, we have to find out this decision boundary or separator. For say, we don't know what is decision boundary, but it's a separator, such that any point it is coming, you can say it is either plus class or minus class. This separator may be a curve, or maybe more complicated and more complicated curve. That may be the possible. This decision boundary may be anything. It is based on the hypothesis function, and by the virtue of this separator, we can find if a new data come, it is going to be grouped or going to be placed in which site. Okay, so this is the basic example of the binary classes. It may be extend to the more than 2 classes, or it's a 3-class problem, multi-class problem may be possible. So in supervised learning, what is the basic goal? To find a separator, so a decision boundary between two given set of data. Okay, so this is, in this case, is a very easy example. So it is a linearly separable this data, so we can get this line. Okay, so input samples are labeled and in red and green, and we have to find the separator. Okay, so that is the main. Now, if these labels are not given, now you see labels are red and green here. You know, there's a red group, it's a green group, but here nothing is given, everything is green. So if this is happened, then we call it is unsupervised. No supervisory, no labeled data is given. Given a set of unlabeled data, the task is to establish the existence of groups on the cluster in the data. Now the question is, how can we do that? But what you just see the data distribution. Now that here it is the thing, to find the cluster groups and data, we have to find some intrinsic structure in the data set. So you can see it is something is here, some grouping can be done. So something like that. It's a natural grouping is possible, but just seeing the data, nothing is given. So this is the intrinsic structure of the data. By virtue of this, by observing this, we can group it out. But okay, that's two things. What are there, we don't know, but we can group it out. Okay, so there is some application of the supervised learning. So it's a clustering is one very important application. That is what we have seen here. This is basically, we'll see later, it's called clustering algorithm, that it is basically grouped in different data. So clustering algorithm used in customer segmentation, document segment, etc. Anomaly detection and fraud detection, cyber security, this unsupervised learning is very much using. One thing we have to understand here, that in practical most of the data is unlabeled, and labeling or annotation is basically a costly process, okay, and the complexity is very high for this labeling. So we have to, this unsupervised learning is a very promising area of research and academics. Then another thing is recommendation system, product recommendation, content recommendation, dimension reduction, that you can say personal, this PCA kind of thing, principal component analysis kind of, data compression, feature engineering, etc. Then NLP is stopped modeling, word embedding, such and such things. Bioinformatics, genetic data analysis, protein structure prediction. These are unsupervised learning are very much used, and this list is not this. We are only write up some few of them. Okay. As we discussed earlier, that in unsupervised learning there is different variants: semi-supervised, fully unsupervised, self-supervised. Now, in this lecture, we are going to introduce just the idea about self-supervised learning. Now, what is the definition of self-supervised learning? That the model is trained on the data set without explicit human annotated labels. That we have to understand what does this mean. Now you can see, since it is unsupervised, no explicit annotation or labeling is not given. But we can get the supervisory signal or some kind of supervisory signal from the data itself. What we can say, that the structure or inherent properties of data can be utilized to get such supervisory signals. Okay, that is basically happened in case of self-supervised learning. To understand how we can get such supervisory signal from mainly the structure or inherent properties of the data, we have to mainly understand three concepts. One is pretext task, that the system sets up a problem that where the answer is already known or can be derived from the data. Okay, now by virtue of this problem and the corresponding known answer, or which can be derived from the data, we can get some idea about this data or some structure or inherent properties of the data. For example, we will see that image colorization may be a pretext task. We will see how it can be done. Then another thing is called representation learning. Actually, when we are learning from this problem and this corresponding this answer which is been derived from the data or already known, this learning actually gives you some idea of representation of the data. Okay, so by solving the pretext task, the model learns a useful feature response representation of the data, and this feature representation learning is called representation learning. Another that may be optional and for our downstream task, for the vision or NLP downstream task, this fine tuning may be required. Okay, once trained, the pre-trained model is fine-tuned data set for the downstream task. Okay, that we will see in later. Okay, let's try to understand by one example where this image segmentation kind of downstream task can be used or can be modeled using image colorization as a pretext task. Let's try to understand by an example. Now this is an object or you can say set of objects, the bat, ball, wickets, and this is the corresponding color. So we can say that this colorization, and there is a kind of automatic colorization technique, so we can colorize it. So this bat is yellow, the wicket is orange, and the ball is red. Kind. This is just object colorization. Now, what is important here, that this kind of thing can very easily done. Okay, so image colorization, this is a problem that answer is can be easily derived or it is known. Now we have to understand, in self-supervised learning, the model is trained for the image colorization, and in doing so, it learns what objects are. You can see when we are colorize it, their different color is given to the different object. So this information we understand, that was not given, that this is a object, these are different object, and ball is a bat, ball, wicket, these are different objects. So what are the objects are, where they are the location, okay, where this, and their shapes and boundaries, their shapes, how the bat looks like and the wicket looks like, the ball looks like. This called the representation, and learning of these informations is called representation learning. So by virtue of this image colorization as a pretext task, when we learn such image data representations or some properties by virtue of this data representation, called representation learning, and that skills that are directly useful to a downstream task for the semantic segmentation. Semantic segmentation basically a downstream task where we have to each pixel we have to colorize, or if we have to classify that this particular pixel is different than others. So we have to say that this is. So this is given this self-supervised for semantic segmentation downstream task. We use this image colorization pretext task. So we can understand that this is a pretext task, and here we can, this is the pretext task, and how we can use for this representative learning by virtue of this pretext task. And then we can maybe for this kind of image segmentation we can fine tune it. So this is a very brief overview of self-supervised learning. Now we are going to discuss a bit different type of machine learning technique. It's called reinforcement learning. So in reinforcement learning is a special type of machine learning where an agent learns to make decision by interacting with an environment. As you see in this diagram, this one is agent. This agent may be a robot, maybe a program or model that takes some action, let's say action A at the state T for a particular environment, and this action is such that it takes the agent to maximize the cumulative reward over time. So what is the cumulative reward? So before understand the reward, we have to understand this setup. There is an agent here, as I said, and there is an environment here. Let's say this is the game. A certain stage of the game, we may be in this kind of state. So as a whole, this gaming environment is called environment. Agent who is going to take the decision, and environment is the given environment as a tic-tac-toe game. Now what is the state? A representation of the current situation. That means given here, now we are, that is 2 cross and symbol and 1 is circle. The question is, what will be the next state or next move, so that a player which is going to put a circle can win the match or at least draw the match. So that is the move, that is the action. So action is a choice that agent can make a state. So given this state, how a particular agent going to take a move such that it wins or at least ensure not to lose the game. And reward is basically measuring the goodness of the move or action. So it's a feedback signal, positive or negative, given after an action. Okay, so in this way we can say that this is the setup of a reinforcement learning, where agent learn to do this kind of moves. Given in a state, it's going to take an action, and this step or this move, it will send to another state and giving some reward. Okay, so this is the thing. Let's try to understand with an example. Now this is the tic-tac-toe. When this is the initial state, everything is empty. Now let's player 1 takes an action, put the cross mark here. This is the first state. And the player 2 takes the action, this they put the circle here. So this is the two-player games. Okay. Now in this way this game is going on. The question is that given a state, let the player 2 is a machine, that how to understand that which position we should put this circle. So question is, which move is good for a player machine not to lose the game? So every state, when it is the machine going to choose, then it has to choose, or it has to choose the position, that where to put these circle marks, so that it at least ensure either win or not to lose. Okay, but that we have to understand here, that this is the different state possible from the initial state, since it's a total 9 position, so 9 possible state depending on which position this card mark is given. And for every such state there is 8 different locations. So if we take this kind of tree like structure, it gives the different states of this plane. Now what is required for a machine, that given a particular state, it can choose a particular move or action such that it will ensure that in this path, this may be winning path, or at least the draw the game, not to lose the game. Now you can say, so the reinforcement learning is basically choosing some policy. So it's a path, kind of the path here, in this a path to here, to here, here to here, and so on. So by choosing a policy, reinforcement learning agent predicts the best possible move, the best possible action towards the target outcome here, not to lose the game for a given state. And how to understand that our move or its move is good or not, that is measured by rewards. So rewards derive the goodness of the move or action to help the agent making decision. Now a move which drives agent towards its intended target, so not to lose the game, that is the target, that is the bag's positive rewards. Otherwise, if it in a different path which he may lose, then this is back the negative rewards. So what is the basic tendency or basic learning strategy? An agent always choose a policy such that it will always get a positive rewards, and that's why this sentence, that in order to maximize the cumulative reward. Okay, so the idea is that agent always choose a policy, it will always get a positive rewards given a state, and thus will fulfill the target. So this is the very briefly the idea of reinforcement learning. So in this lecture, what we have learned, first we given the definition and application of the machine learning. Then we understand the difference between programming and learning, and we basically discussed few types or different types of machine learning, giving some examples of supervised learning, unsupervised learning, reinforcement learning. In the next part, in part B, we start the supervised learning, specifically regression. Thank you.